an asteroid is basically a lump of rock that orbits the Sun just like the Earth and the other planets do, but this one's coming particularly close to the Earth. It's actually it's the biggest one that's come this close that we've been able to sort of record, you know, with telescopes and so on. So I've actually brought a little prop to sort of explain.
Okay. Right. Yes.
So this is your standard model of the Earth, basically. So if this football with the Earth.
So this is us.
So this is us on the Earth. If we had the Moon in the same thing, it'd be about the size of a tennis ball, but it would actually be sort of 30 feet over there, basically. So if we get rid of the tennis ball,
right,
that's way over there. And the meteorite, the asteroid, I should say, is tiny. So it's really, as you said, Olympic swimming pool size. So maybe half the size of a football pitch. If you could imagine that on the Earth here, that would be tiny. So if we had that asteroid here, then it's basically about this far away from the Earth. So it's basically coming past at about this distance, so way closer than the Moon, even closer than the orbiting geostationary satellites, like your sat-nav satellites are farther away, so it's coming inside those. So this is, you know, really unusually close.
And how visible will it be?
Yeah, that's the challenge. I think for your average person, I think it's quite hard to spot. You certainly wouldn't see it with the naked eye. Its closest point is about 7:30 tonight. And from this country, if it were clear, then it would rise in the east just after 7:30 and work its way up the sky towards the north, towards the constellation of the Plough. And it would reach there about 10 o'clock. So if you can imagine it sort of appearing about 8 and moving across the sky until about 10. But you would need binoculars to see it, and even better, a small telescope.
The trajectory, the direction of travel, doesn't change? I mean, it must change sometimes. How can you be so sure of where it's going to go?
Yeah. I mean, generally when these things are orbiting the Sun, something can perturb the orbit. So in the case of coming round the Earth, the gravity of the Earth itself can cause the orbit to change direction like this. And in fact, at the moment, it's orbiting the Sun with a period about the same as the Earth orbits the Sun, so just over a year. But by this interaction with the Earth, by coming quite close to the Earth, the period's going to change to about 300 days, 320 days.